Dear students, how many of you know there is a relation between orbital angular momentum and degenerate orbitals formed? See here in this class we are going to learn what is the relation between number of degenerate orbitals formed and orbital angular momentum. There is a connecting link between these two things, that is angular momentum quantum number L. Let us check it. Hi dear students, in last class we learned how to calculate angular momentum. Angular momentum is equal to nh by 2 pi. Now in this class we are going to learn orbital angular momentum. See here, angular momentum L is equal to nh by 2 pi. Here orbital angular momentum is equal to root of L into L plus 1 h by 2 pi. See here, in calculating angular momentum, the principal quantum number plays a key role, whereas in calculation of orbital angular momentum, the angular momentum quantum number, that is azimuthal quantum number, plays a key role. See here, from this equation we will calculate one thing. What is the orbital angular momentum of an electron in 2s orbital? 2s orbital. See here, if it is a 2s orbital, what is L value for 2s orbital? L value is equal to 0 for s orbital. Okay, L is equal to 0 for s orbital. See here, if you substitute the values here, L is equal to 0. 0 plus 1 h by 2 pi, that is equal to 0 plus 1 1, 0 into 1 0, h by 2 pi, that is equal to 0 into h by 2 pi, nothing but 0. I hope it is clear to you. Once again check it. Orbital angular momentum is equal to root of L into L plus 1 h by 2 pi. Now we are calculating the orbital angular momentum for an electron present in 2s orbital. For s orbital, L value is equal to 0. If you substitute the L value 0 in the given formula, then we will get 0. Okay. Now we will calculate one more calculation. Please note down this one. Now we have one more calculation. The magnitude of an orbital angular momentum vector of an electron is root 6 h by 2 pi. Into how many components will the vector split if an external field is applied to it? External field applied to it. See here, there are two types of external fields. One is magnetic field, another one is electric field. Splitting of spectral lines in presence of magnetic field is called Zeeman effect. Splitting of spectral lines in presence of electric field is called Stark effect. We already learned those things in our previous classes. Now in this calculation, we are going to check what is the relation between the splitting of spectral lines and orbital angular momentum. Okay, we will find out. See here, what is the formula to find out orbital angular momentum? That is equal to root of L into L plus 1 h by 2 pi. If you observe this one, they given the value of this one as root of 6 h by 2 pi, means that is equal to root of 6 h by 2 pi. Now from this one we can find out L value. See here, h cancel, 2 pi, and that is equal to root of L into L plus 1 is equal to root of 6. If you simplify this one, we will get L square plus L is equal to root 6. Root get cancelled with each other. Then L square plus L is equal to 6. It is nothing but 2 square plus 2, that is equal to 6. That means L value is equal to 2. If L is equal to 2, what is the orbital? If L is equal to 0, s orbital, L is equal to 1, p orbital, L is equal to 2, d orbital, L is equal to 3, f orbital. Now our L value is 2. From the given data we calculated L value, that is 2. That is d orbital. See here, we know that in presence of an external field, it may be magnetic field or electric field, d orbital splits into how many components? 1, 2, 3, 4 and 5 components. What are those? dxy, dyz, dzx, dx square y square, dz square. These are the 5 components. Now see here, into how many components will the vector split if an external electric field is applied? How many components? 1, 2, 3, 4, 5. 5 components. How many components? 5 components. In JEE exam, they will ask such type of questions under numerical section. We have to link these things. To link these things, we must have knowledge about angular momentum, orbital angular momentum, and L values of different orbitals, and splitting of orbitals like p, d and f orbitals in presence of external fields like magnetic field and electric field. Okay, and this is one of the most important calculation which has several relations to find the components. Okay, please note down this one and we will move to next one. Just now we calculated a few calculations on orbital angular momentum. In addition to orbital angular momentum, there is one more, that is spin angular momentum. What is the spin angular momentum? Spin angular momentum is equal to root of s into s plus 1 h by 2 pi. See here, a small variation between orbital angular momentum and spin angular momentum. I will write orbital angular momentum also here. Orbital angular momentum what is orbital angular momentum? That is equal to root of L into L plus 1 h by 2 pi. H by 2 pi is common here. Here orbital angular momentum is calculated based on L values. L is nothing but angular momentum quantum number, or you can say azimuthal quantum number. Here in case of spin angular momentum, formula is the same, but here instead of L we have S value. Here S is nothing but spin quantum number. The value of spin quantum number, it may be plus half or minus half. And in these calculations, to calculate spin angular momentum, we will take the positive value plus a half. And see here, if you like to take the ratio between orbital angular momentum and spin angular momentum, because in JEE exams and NEET exams, generally they will ask the ratio between orbital angular momentum and spin angular momentum of particular orbital. For example, if you consider p orbital, what is L value for p orbital? For a p orbital, what is L value? L is equal to 1 for p orbital. Now we will substitute, now we will take the ratio here, that is, we will substitute the L value. L is equal to 1 and 1 plus 1 h by 2 pi, and here S value is plus half h by 2 pi. H by 2 pi is common in both the cases, that's why I like to cancel these two things. Next, if you simplify this one, 1 plus 1 2, 1 into 2 2, that is equal to root 2. See here, half plus 1, if you simplify this one, you will get 1 and a half, means 3 by 2. Here 1 by 2 is there, root of 1 by 2 into 3 by 2, that is equal to root 3 by 4, that is equal to root 2 by root of 3 by 4. See here, what is the root of 4? Root 4 is equal to 2. Then we can write it as root 2 by root 3 by 2. And we can write it as 2 root 2 by root 3. What is the ratio of orbital angular momentum and spin angular momentum of a given p orbital with L value is equal to 1? It is nothing but 2 root 2 by root 3. These are the different ways to ask questions. Don't expect direct questions in JEE and NEET. They may ask different relations, and they will ask the relations, and they will ask questions based on different relations among the different formulae of same concept. Okay, please note down, and it is one of the important concept. In this class you learned orbital angular momentum, spin angular momentum, and what is the relation between orbital angular momentum and spin angular momentum. Okay, please note down this one, and please follow our channel Mr. Chemistry to get the updates related to JEE and NEET. Thank you all of you.